Hey guys, Mr. Hames here in my classroom doing a lab that we commonly do here in 8th grade. It explores a common chemical that I'm sure you guys ingest on a daily basis, probably more than you should in a single day to be healthy, and that is sugar. Now the reason we're looking at sugar is because sugar can be changed in a lot of ways. We are going to be altering or changing sugar many times in the lab today, and your job is to take good observations of what you see happening to the sugar. Most of what we're going to take are qualitative observations. That's things that you see, taste and color and size and shape and all that kind of stuff, things that we would observe with our senses. Now sugar, let's talk about the chemistry of it. The molecule for sugar is C12H22O11. That means that it is made of C, carbon, H, hydrogen, and O, oxygen, all elements that you can find on the periodic table. The number of atoms are designated by the subscripts in there, which you might have heard is 12 carbon, C12, 22 hydrogen, H22, and 11 oxygen, or O11, making up the molecule in total, 12 carbon, 11 oxygen, and 22 hydrogen. So pretty cool molecule. All right, so what we're going to do is we are going to chemically and physically change sugar in this lab. And your job is to differentiate when a physical change is happening and a chemical change is happening. But for me, I'm really interested in not can you just identify it, because I think it's easy, but can you tell me why a chemical change is happening when it is, and why a physical change is happening when it is. All right, now that you've had enough background, let me show you the lab setup. Okay, so you can see that I have a little lab set up here with various materials that we're going to be using, some of which we'll use for the lab itself, some of which are just for safety, like these goggles, which will come in handy when I use this guy over here, which is a Bunsen burner, which follows this hose up to the wall and is connected to a gas jet that distributes natural gas once I turn that on. Some of the other more basic tools we're going to be using is over here. We're going to be using a beaker with a coffee stirrer in it. This is a mortar and pestle. We'll be using that. And then here we got a test tube rack carrying a couple test tubes. We're going to be using test tubes in addition to these two little guys here. Our first one right below here, these are forceps, aka tweezers. And this is a test tube holder. So basically it's a clamp, kind of like tongs that I can pick up the test tubes with if they get hot or there's something inside that could burn me. So here's what we're going to be doing. These guys over here, these are sugar cubes. Okay, all it is sugar that you're used to seeing granulated, okay, in little tiny irregular chunks. They look like specks, but if you look at them up really close, they're like little granular chunks. It's all been packed together into this nice little neat cube, so that's what we're primarily going to be working with. Oh, I almost forgot. Over here on this side of the room, I have a microscope and stereoscope set up just in case we wish to view this underneath a microscope or stereoscope, see it a little bigger. Okay, so I am going to be changing the sugar cube in various ways. So first we are going to look, before I destroy this sugar cube, just what it looks like. Like I said, all of this is sugar compact into a tiny little cube. Let me get my fingers out of there so you can just look at it. Now what your job is to do is to take what are called qualitative observations. You're observing them primarily with the 5 senses. We will try to take one quantitative observation here in just a minute, but most of what you're going to be writing down are kind of subjective in that you are going to describe what it looks like in size, shape, color, taste, hardness, texture, okay? So let's start with size. Now you can see it compared to my fingers, but it really gives you perspective as to how big this sugar cube is, right? Okay, it's really only about as big as the very tip of my finger, maybe the same size as a thumbnail, only the sugar cube is has a little more depth in terms of 3-dimensional quality, okay? If I really want to be specific, I could take a ruler and measure it in centimeters here, okay? And when I do that, okay, I come up with 1.69 cubic centimeters, 1.69 cubic centimeters, length, width, and height all multiplied. In terms of shape, it is in the shape of a cube very easily. Each face is either a square or a rectangle, making this a cube or a prism. The color is white, okay? It does have a little bit of shininess to it. As you can see when I turn it with the light, there are some areas that reflect the light, okay? When you look at it really close, something with texture is now you can see that it's not just one big smooth surface. It's kind of coarse and rough in texture, and that's because the sugar cube is thousands of those tiny little granules of sugar chunked together into one cube. In terms of hardness, it is pretty hard, but if I take it and I kind of just scrape it on the table, don't worry, I'm not scratching the table. That's actually the sugar that you see scraping off of the cube. You can see I kind of shaved it off very easily. So it is hard, but it has a little bit of give to it in that when I scrape it, I can easily take my fingernail even, and you can see I can scrape all those pieces of sugar off. Okay, so now what we're gonna do is I'm gonna take my mortar and pestle, and I'm going to grind the sugar up using this little mortar pestle here. Okay, I think I'm almost just about there. Let's take a look. Pretty tell it no longer looks like a cube. Let's pour some out onto the table right here. It's very powdery, as opposed to even what regular store-bought sugar looks like, where it's kind of a little bit more grainy. I don't know if you can tell the difference there, okay? But the stuff on the right is a little chunkier than even the stuff on the left. It's a little more kind of powdered form, kind of like powdered sugar. It's definitely a lot finer in texture, okay? As you can see, almost like powdered sugar. It feels a little gritty, but when I touch it softly, it feels smooth, kind of soft and fluffy. Let's pour some more out here. The color has not changed. The color's still white. If anything, it's a little brighter, although I don't see as much shininess in there as I did before. Let's rotate the camera and see if we could catch any light. It's lost some of its luster or shine as opposed to the grains here. Okay. Oh, and of course tastes, okay? So let's go ahead and give it a taste. Ready? Here it goes. Yummy. Tastes just like sugar. All right, let's go to the next step, which is adding the sugar to water. Get it in there. All right, and now we stir. You can still kind of see it's on the bottom here, so I'm gonna stir until we see sugar no longer. Take a close-up look at this. I don't see any sugar in there. So if we're taking observations on this part, I see no pieces of sugar floating around there. In fact, the water doesn't even look cloudy. It looks perfectly clear. So size, can't really say I can determine a size just by looking at it, nor can I determine a shape. If I'm talking about the shape of the water just takes whatever shape the container, the beaker is. Color, can't see the sugar, but I do see some water, so I'll just say the water's transparent. As far as taste, I guess I could kind of taste the water. Maybe I can do that now. Ready? Okay, tastes like water, but it kind of tastes sweet, like as if it was, I don't know, some sort of sugary drink that was really watered down. Though I can detect sweetness, which tells me that the sugar's somewhere, possibly, in the water, okay? We'll talk about all the answers to this later on, but I can tell you it does taste sweet. Okay, now it's my favorite part of the lab, where we are going to light this Bunsen burner. So give me just a moment to do that. All right, now as you can maybe see, the flame here is very clean burning, okay? In fact, without a background, it's hard to see a flame at all, but there is a flame here. The color of the flame is blue. Let's see if I can turn this so you can kind of see it. My shirt has too much blue on it, so it's not super great. But trust me, there is a flame there. What I'm going to do here is I'm going to burn sugar. I've put it in a test tube here. And what I'm going to do is I'm going to hold it with my test tube holder. I'm going to hold it right into the flame there. I don't know if you can see. Let's go closer. I'm holding the base of it right in the flame, and I'm kind of holding it at an angle to increase the surface area. My goal is to get that test tube as hot as possible. Okay, don't worry, the test tube is made of borosilicate glass. The glass is the same stuff you might make Pyrex out of, so it is capable of getting very, very hot and doing it safely. Now, watch what's happening here to the sugar. You can see we got color change going on. It was white, kind of started to a light brown. It was solid, it's turning to a liquid. That light brown is becoming a much, much darker brown. Hearing a lot of gurgling in there. Gases being produced, bubbles. A lot of bubbles happening down here. I've got no white left, no light brown. It's all become a very dark brown. Wouldn't call it black just yet. Let's look up the test tube here. I'll bring it away from the flame just a minute. You can see it's bubbling and things like that. I can see condensation, some sort of liquid forming droplets on the test tube. I'm gonna keep going. I really wanna make sure I really burn it. Let's look at the test tube up here. You can see there's heat rising out of the test tube, and what you're actually seeing is some sort of fog or smoke exiting the top of the test tube. Let's keep going. Wow, it's really expanded in volume. It's taking up a lot more space in the test tube now, isn't it? And it's really not brown anymore. It's almost like a dark black. If it is brown, it's such a deep brown that it almost appears to be black. Look at that. Look at that smoke or fog. It's kind of turning a yellow color. Look at that. See more condensation with some yellowing inside of it on the interior of the test tube. That's the inside of the test tube. I wouldn't want to touch the test tube right now because it's really hot. I'm going to keep going, keep burning. I still see some bubbles in there, which shows I have that liquid. Anything that I burn tends to expand and turn darker, so I want to keep going. Remember how when I had the sugar in here, it only took up like a little tiny, like maybe that much of the test tube? Now look at how much of the test tube is full of something. I don't know. I'm guessing you guys are making obvious connections here, but there's a lot about this that doesn't look like sugar anymore. The question is, what is it if it's not sugar? This is so awesome. Of course, I'm doing this safely. I have goggles on. Ooh, what was that? A little flame there? I like that. Look at that. It was a little on fire. Let's see if we can get the light on fire again. Why? Because it's kind of fun. Okay, now, the goal of this lab is to not only determine when a physical change has happened, as opposed to when a chemical change has happened. If you're thinking the right track, look at that little flame on there on the top of the test tube. I'm gonna go ahead and shut off my Bunsen burner so I can get that out of the way. If you're thinking that perhaps a chemical change has finally occurred, you're thinking the right direction. The question is, why are you thinking that way? So what evidence have you gathered at this point to go that conclusion? What I mean by chemical change, when a chemical change happens, it means the substance has completely changed what it is. The molecules that make up that substance have rearranged themselves into a different substance altogether. So sugar was C12H22O11. If a chemical change were to have happened in this case, which we're thinking it did, those atoms should have broken apart and reformed into new substances. The question is, what are those substances, right? Well, whatever the new substances are, we know what they're going to be made of. They're going to be made of either carbon, hydrogen, or oxygen, because if sugar was C12H22O11, we knew it was made of carbon, hydrogen, and oxygen. And unless there was some unknown reactant in this test tube that reacted with the sugar, we know that those atoms are going to have to be accounted for. Something called conservation of mass. The mass of the atoms going in to the reaction and the reactants has to be the same in the products, whatever's produced. Why am I doing so much talking? I want to smash this thing. Let's do it. Okay, what I'm doing now, it's not super hot anymore, so I'm going to start rolling this in the paper towel. It's kind of like the Jimmy John sub sandwich roll, right? You roll and then you tuck the sides. You roll and then you tuck the sides, okay? The only reason that I've done that is actually for safety. And what I'm going to do next is something that I've really been wanting to do since I pulled that test tube off the Bunsen burner. I wanted to smash it. So I'm not going to smash it hard. I'm just going to smash it enough to break that test tube. Oh, I'm sorry. Were you emotionally attached to the test tube? I guess I should have given you a moment to kind of say goodbye. No one. Okay. Let's unravel it and see if we can get a better look at what's going on here. Wow, check that out. Okay, so you can see the test tube is clearly broken. Let me take a couple of these pieces away. The reason I have my forceps is so I don't have to touch the glass with my fingers. I don't want to risk getting cut. Crispy comes to mind when I think of the texture. Okay, I can kind of break it, but it quickly breaks apart. It does not want to focus. Let's try to find a bigger piece. Okay. There is a larger piece. Okay, so this stuff is a very, very, very dark brown, okay? Nearly, right, black in color. But it's shiny, it's not dull, right? It has some pieces that are reflecting light. You can see, whoopsies, boy, it's really hard to hold on to with these forceps. I'll do my finger, okay? As I turn it, you can see that there are some crystals in there that reflect light, okay? So it's not completely dull. You can also see, I can tell you this is very light. Okay, this is extremely light. Very flaky, very fragile. In fact, if I just put a little bit of pressure on it, okay, it kind of breaks and crumbles. It doesn't hurt my finger to do so. Okay? I'm just wanting to focus more on my fingers than the black stuff itself. Okay, so that should give you a close enough look. Size is different size than we started with. The shape I would call irregular, okay? It conformed to the shape of the test tube. It used to be a liquid, but it's turned into a solid now. Its color is brown or black as opposed to white, what we started with. Its hardness is, it's less hard even than sugar is. It flakes and breaks apart very easily. I'd call it brittle. And its texture is not smooth, okay? Its texture is kind of flaky, maybe a little coarse, maybe a little spiky in some spots. It's porous. There are holes in it where air would fill those holes. I guess the only last thing to do is, unfortunately, try to taste it, which is what I'm about to do. To prove I ate it, that's my tongue. Sorry, not to show you stuff. It doesn't taste like food. In fact, I don't think I want to swallow this. Very gritty, very crunchy. It tastes like that stuff if you overcook a steak and you kind of scrape off the really, really burnt part and try to eat it. It doesn't taste like steak at all. It just tastes like this nasty burnt char. Yeah, that's definitely what it tastes like. Very bitter, very gritty. No sweetness to it whatsoever. No flavor to it whatsoever. I don't want to eat any more of that. So hopefully that gives you enough observations as to what perhaps this stuff might look like based upon the observations you took on camera, okay? So that's a pretty solid chunk there. It's a pretty solid piece. Oh, I know what I forgot to do. I forgot to put it on a microscope. So what I'm going to try to do, just so you have some pictures of the sugar on a microscope, is put it on a slide so you can see what this looks like when it's magnified much larger than its own size. Maybe we pick up on some things that we didn't with our observations. So keep your observations ready to go as we look at them underneath a microscope. Oh, wow. Now that is like really cool. What you're seeing is the sugar magnified to be 40 times the size than it actually is. What you can see here is we kind of lose that white appearance. It kind of looks gray, but what you're actually noticing is it's translucent, it's transparent. Okay, there's a light on the microscope. I turn on or off. Okay, there it is, real color. You see the whiteness a little bit more because it's reflecting a lot of the room light, so it appears white to us. But when I put a light behind it, we can see that light can actually also shine through. So now there's backlighting involved. And the shape is really interesting. Some are kind of cubes, some are not, some are like trapezoids. It's irregular shaped, but it doesn't have round edges. It's not round, okay? It has multiple flat surfaces. It has a crystalline structure, we call this. So the molecules align in a way that's kind of uniform or interesting that creates these edges or angles on each piece of sugar, and that is a crystal, okay? A crystalline structure. When the molecules link up to form this kind of crystalline structure. Okay, so that is granular sugar. Let's take a look at what the sugar looked like when I ground it down into powder form, shall we? Oh, wow, okay, it does not look the same. Okay, so now we kind of get some of the larger structures, but we lost that kind of crystalline structure. It doesn't seem, at least on this objective power, to be as chunky. Gosh, I'm really struggling to come up with a science word to describe this. The shape is still irregular, but now it looks more like chunks of powder than it did solid pieces. We also can't seem to see through those pieces as much anymore. Let's see what it looks like with the light off. Okay, yeah, it looks like chunks of powder, like snow or something like that. Let's see if I can do it on my next objective. This is about 100 times the size of what it actually is. Okay, oops, I moved my coarse adjustment. Let me try my fine adjustment. Let's see if I can go even one higher. Now this one might get dicey because I don't have a cover slip on here. There we go. I'm gonna move it just a little bit. I'm moving, moving the slide on the microscope. This is as big as it's gonna get, folks. If you're wondering what I did, I switched it over to high power. We're seeing it 400 times its size in reality. Uh-oh, I lost it. We're seeing it 400 times its actual size. There you go. All right, let's see what that black stuff looked like. Remember, after burning the sugar, this is what I ended up with. Interesting. Kind of looks glassy. If you were to take a brown bottle and break it, that's the glass that you would have left over. It's as big as I can make it on camera. Let's see if I can... Well, first let's see what it looks like when I turn the light off. Okay, yeah, it looks like obsidian glass or something like that. Obsidian is kind of the smooth lava rock. You know what I'm talking about? Let's see what it looks like on medium power. Gives you a little better perspective for your observations. So anyway, this is what it looks like after we burned it. This is that black stuff in the test tube. You can see irregular shape, kind of looks glassy, brown. Some light is able to kind of shine through it, maybe it looks like a lighter brown. Some of the thinner pieces, the light kind of comes through a little bit there. So anyway, it gives you a perspective. Okay, so anyway, 8th graders, this is the initial part of the sugar lab. We will talk about this more in depth. If you're watching and you just got to know right away, you can click the video that's popping up on the screen right over here. That goes into the chemistry of what's occurring. But before you do, just think about the molecule of sugar. What are the atoms that make it up? And you should be able to start predicting what's going on here. See you next time, and we are going to go over the chemistry of sugar burning. See ya.